Hello everyone. In today's video, we'll be talking about infinite geometric series. So if you haven't watched the video on geometric series, the previous video that I did on this, go ahead and watch that first because we're going to use some of the information from there to talk about infinite geometric series. So what is meant by infinite geometric series? It's essentially exactly what it sounds like. It's a geometric series that's infinite. It goes on forever and it never stops. So let's look at a quick example of what we would call an infinite geometric series. For example, 2 plus 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus so on. If we keep doing this forever, we would call that an infinite geometric series. So if we refer to something like this as an infinite geometric series because it keeps going forever. Okay, now surprisingly, even though these are infinite, we still have a way of finding the sum of this. So for specific conditions, if a specific condition that we'll talk about in a second is met, we can actually find the sum of an infinite geometric series, which is very interesting. So here's the formula for it. I'll go through the derivation of this formula at the very end of the video, but for now, let's just have a look at the formula and how to use it. So S infinity is equal to A over 1 minus R. So 1 minus R. And there's one condition that has to be met in order for us to be able to use this formula, and that's that R has to be between -1 and 1. Sometimes it's also written like this. Absolute value of R has to be less than 1. Okay, so let's go ahead and explain this formula a little bit. S infinity refers to the sum of the first infinitely many terms. So what's the sum of the first infinitely many terms? Well, it's the sum of all terms, right? All infinite terms. So this is equal to the first term, right? Which in this case is 2, right? A represents the first term, divided by 1 minus the common ratio. Now, again, this is super important. This formula only works, it's only valid if the common ratio is a number between -1 and 1. So just to make sure we have a good visual understanding of this, if this is a number line, and we have these numbers, so the common ratio can be anywhere between, it can be any number between -1 and 1. It can't be equal to -1 or equal to 1. But as long as the common ratio is anywhere between -1 and 1, then we'll be able to use this formula. Okay? All right, so let's do a quick example of this. We'll actually just solve the example on top here. So let's say somebody asks you to find the sum of, an expression like this. 2 plus 1 plus 1/2 plus 1/4 and so on. So the first thing we have to do is make sure that this condition is met. Okay? So let's see. What's the common ratio here? Well, we can see that terms are getting cut in half every time. So the common ratio in this example is 1/2. Again, just as a reminder for everyone, the way we can find the common ratio, if you don't want to do it by just looking at it, is by taking a term, like 1/2, and dividing it by the previous term. So in this case, 1. And that'll give us the 1/2. Okay, so here, the common ratio is 1/2, which means our condition of R being between -1 and 1 is satisfied. So we can use the formula. So S infinity, the sum of the first infinitely many terms, is equal to A, the first term, which is 2, all over 1 minus the common ratio, 1/2. Okay, now what is this going to be equal to? Well, we get S infinity is equal to 2 over 1 minus 1/2 is 1/2, and 2 over 1/2 is equal to 4. Okay, so and this should be, hopefully you guys find this as interesting as I do, because this never ends, right? It's an infinite series, it's an infinite sum, but somehow its total value comes out to exactly 4. Okay, and that's, I think, very neat. So yeah, that's how we can use the formula. One thing to keep in mind for this is what happens if we can't use this formula. So let's say we find a common ratio, and the common ratio isn't between -1 and 1. Let's say, so let's write this down. When R, or let's say when this is not the case, so when R is greater than or equal to 1, or less than or equal to -1, then the sum is said to be divergent, And what this word means, divergent, means it doesn't come out to a number like 4. It doesn't come out to a final value. Okay, so it could mean that the sum oscillates between two numbers. We won't really think about that case too much for now. So there's two things that this word divergent can mean. One is the sum goes to infinity or negative infinity. And the other one is that the sum oscillates. Okay, so let's write that down. Okay, so those are the two cases. The sum can either go up to infinity or all the way down to negative infinity, or it can oscillate. And in those cases, that essentially means the sum doesn't exist. We can't do anything. There is no answer. So we just leave those problems alone. When the common ratio is between -1 and 1, we say that this sum, so I will write that down here, when R is between -1 and 1, we say that the sum is convergent. So that means it comes out to a specific number. So we gives a final value, like the example we did above. So this sum above, let me circle it, this guy that we did together, the sum came out to a final value. We ended up getting a number for that. And so we would call that a convergent sum. Okay, so that's going to be it for the lesson for infinite geometric series. In the next video, we'll go over a whole bunch of practice problems as usual to practice with the concept of infinite geometric series. Now, I have an additional bit at the end of this video. So I'm going to go through the derivation of this formula, and the derivation is actually maybe 30 seconds. So it's not necessary. If you guys want, you can go immediately to the next video and watch the practice problems. But I encourage all of you to stick around for maybe 1 more minute. Okay, so let's see where this formula comes from. So I'm going to write down the sum formula that we came up with back when we were talking about normal geometric series, not infinite ones. So this was the formula, and I did go through the derivation of this. If you're interested, go watch the previous video on geometric series, and you'll be able to see where this formula came from. Okay, now the only new thing we need to know is that n here is infinity, right? We are finding the sum of the first infinite terms. Okay, and there's only one property that we need to know about. We know that this formula only applies when r is between -1 and 1, right? Why is that? Well, because when r is between -1 and 1, that's going to be a number whose magnitude is less than 1. For example, 0.5. So let's ignore, we won't think too hard about negative numbers. The logic is exactly the same for negative numbers. Let's just think about a number that's less than 1 and greater than 0, like 0.5. Okay, so if that's our common ratio, here's what's going to happen. If you grab any number that's between 0 and 1, and you raise it to the power of infinity, you get 0. Okay, and you guys can test this out at home on your calculators. Put in any number that's less than 1 and greater than 0. For example, 0.9. What does it mean to raise this number to the power of infinity? It just means, actually, for an example, let's just stick to 0.5. To raise something to the power of infinity, it means you're multiplying it by itself infinitely many times, right? So you keep multiplying it by itself. And if you guys try this on your calculator, every time you multiply 0.5 by itself, it becomes smaller and smaller and smaller. Okay, so if you keep going, the numbers keep getting smaller and smaller and smaller. And so if you do this infinitely many times, you essentially get 0. Okay, so then in this formula, we can set this equal to 0, because again, if r is a number between -1 and 1, and we raise that to the infinity, that goes to 0. So this becomes a times just 1 minus 0 over 1 minus r, and this is a times 0 minus 1 is 1, so that's just a over 1 minus r. So that's where our formula comes from. Okay, I hope you guys found this video helpful. That's going to be it for this video. Go ahead and watch the next video, and we'll go over a whole bunch of practice problems. All right, see you guys in the next one.